Hey there. So I'm making this video because I found out that about half the people who apply to a software development job can't pass a basic fizzbuzz test. You're probably wondering what the heck a fizzbuzz test is, and don't worry, I'll explain that in a little bit. I'm doing this because I want everyone who applies to a job like that who has had a college degree to be able to do at least simple tasks. Some colleges teach you what to think instead of how to think, which is great if you never want to be good at something, but just know a lot about it. Like the fishing village, that they know everything about fishing. They specialize in everything about fishing, but the only thing they don't do is fish. So anyway, I hope this video helps you, and I hope you're never confronted with such a massive challenge as a fizzbuzz test without being well armed with how to think. So first I'm going to start with a concept that I call R3B3. It's no newfangled thing like ideating. It's just a basic set of things that you have to keep in your mind whenever you're doing any software development task. R3B3 is exactly like R2D2. The only difference is it has more R and B. I'm just kidding. What R3B3 really is a couple of things. It is requirements, research, resources, and baby step building blocks. To explain a little bit further, I'll use the fizzbuzz test as if it was some sort of software development project that you actually had to do. So I'm going to do a scenario with you and a stakeholder. So the stakeholder asks you to write a simple program that counts from 1 to 1,000 and displays each number. When a multiple of 3 is reached, then display fizz instead of the number, and every multiple of 5 display buzz. If there's a multiple of 3 and 5, display fizzbuzz. Sounds easy enough. Before I get into too much further about a stakeholder, there's a few things you need to know. For starters, a stakeholder does not come to you with requests because they love your award-winning personality, as surprising as that may be. They need something that they can't buy off the shelf, and that's why they come to you. That's why you have a job at all. So another thing to remember is, even though you're speaking the same language, you should never assume that you're speaking the same language. So you always verify what the stakeholder is saying. In the example that I gave in the previous slide, you want to ask the stakeholder, hey, should I go from 1, 2, and then write the word fizz, and then 4, and then buzz, and, write it out like a line? And the stakeholder says, no, you dummy. That's not what I meant at all. This is why you verify your understanding with their understanding, because there's a good chance you're not actually speaking the same language. So then you make another attempt. Do you mean write all the numbers in a different row, one after another, and when you reach 3, write fizz, when you reach 5, write buzz, so on and so forth, and then on a line where it's both 5 and 3 multiples, write fizzbuzz as one word? And of course the stakeholder replies, yes, that's exactly what I want. That should be really simple because it looks really simple, shouldn't require much work at all. So now you have to translate what they wanted into something that is actually doable for you. So this is where the requirements come in. You know that the requirements are, you need to write a simple program that displays output. Alright? The program will increment a lot of numbers, 1 to 1,000. You need to display each one. The program will check for conditions of the number. First condition checks for multiples of 3. Second checks for multiples of 5, and the third condition just checks to see if neither the 3 or 5 condition are met to display the number normally. So now that you have your requirements laid out as far as what it is specifically that you have to do, you need to do a little bit of research if you don't know how to do it already. So you research, okay, a C language will be good for just basic console output. We're just making a simple program after all. I know that the printf function is needed for basic console output to display numbers and words like fizzbuzz, and that the printf function needs the std.io library in order for it to work. So you have to include that in there. So that leads to the resources. So now I'm taking a baby step just to be able to display console output of a simple program, and I brought in the printf statement and I included the library that was required for it, which is the std.io library, and I put it in a basic entry point which is called the main function. And now I'm going to compile it and watch all the errors come back. Hopefully not. And sure enough, there were no errors, which is totally normal, happens all the time. You almost never get errors on your first try. That was sarcasm. So basically you took a baby step in printing something to the console, just to prove that you could at least do that, because you never want to just write the entire program all at once, because chances are it's gonna bomb out. So you want to verify each thing one at a time before you progress further into the program. That is a building block, because now you can do something. So now we have the first requirement met. That is a simple program that displays output. It's basically a hello world program. But hey, that's a building block, but now I need to go and do some more research to fulfill the next requirement. That is a program that will increment a lot of numbers. When I did my research, which I didn't actually do because I actually know all the stuff, but if I was someone who had to do research on this, I would have found a for loop as being the best thing to use to increment a whole bunch of numbers. I would also find that I would need a variable to hold the incremental value, so I'm just going to call it x. By the way, don't ever call it x unless it's like an actual coordinate, but whatever. I also found that the printf statement with the %d will actually be able to display the value of x, so that's how I will be able to display the number that I'm counting. And I also found that the \n will display a new line, so it'll be one line after another, which is what you verified when you were talking to your stakeholder. So that's my research. Now I need to gather my resources. So here's my code with the resources. I have a variable, which is an integer, because I'm just counting whole numbers. I start the for loop at 1, and I go to less than 16 because it's going to go from 1 to 15. This is just to prove that example that I used when I was talking with a stakeholder. You don't want to necessarily do the entire 1 to 1,000 because you need to prove the concept at a low level first. So I have my for loop, I got my printf, I got my %d, and I got my \n. So those are my resources, which I'm about to compile, and it will work perfectly the first time because I made this video, and if it didn't, you'd never know. And voila, you have a program that counts from 1 to 15 with each number on a different line, and this is a small scale test to basically make something that's exactly like the example that you verified with your stakeholder. Another building block done. Alright, on to the next thing. So now I continue my research, and I need to check for a condition where the incrementing value of x is equal to a multiple of 3. I found out through my research I will be using an if statement to compare the two, and since there are the two, that means I need two separate variables, or at least I should. I'll explain that later. Just kidding, I won't. So I'm going to use a variable of x with a big old T, because that's camel case. That's for every x value that is a 3 multiple, hence the xt. And in this situation, I'll have to increment that. Every time I have a multiple of 3, I need to increment that variable of xt by 3. So I find out that I need to use the plus equals 3. So let's try that. So now I bring that resource into my code, and I do my conditional statement here, if x equals xt, only this time I'm going to printf fizz instead of the number, and I want it to be on a new line, and then I have to increment that xt variable by 3, so the next time I compare it, it'll be at the next increment of 3. But instead of just allowing the next line to print the number, I'm going to use the continue command and jump over that into the next iteration. So let's see how that works. And of course that compiled perfectly with no errors, which always happens. Just kidding. No, so now I found out, sure enough, every multiple of 3, it displays a fizz instead of displaying the number. So that worked perfectly. That's another building block. But now I gotta go back to my requirements and do some more research for the multiple of 5. So not much research here. I basically just create another variable, and like the xt, I will call it xf for a multiple of 5, and basically do the same process. So for a resource, I'm just going to copy and paste my xt block, and I'll just change it to xf. I added the new xf variable starting at 5, and I increment it by 5. I do the same thing, and we'll see how that works. And sure enough, another building block. Only difference is this one didn't satisfy the last requirement, but it's still a building block because we see that, sure enough, every multiple of 5, except for the last one, displays buzz. But that's where the last requirement comes into place. So we have to do a little bit more research and see how to fulfill that. So before we continue with that, we need to look back at the example we used. We did 1 to 15 for a reason, because when 15 hit, that was the first time 3 and 5 shared the same multiple, and that one had to display fizzbuzz as one word. So we hit every requirement up until that point, and that is where the last requirement comes into play. So like every good software development project, the last requirement, the last 10% is what's going to give you the most grief. So we look back at our code here, and we found that basically what's happening is every time it does the 3 increment, it's basically skipping over the 5 increment block because I'm using continue. So we have to change our code, and that is going to require a little bit more work. So we'll do a little more research. So the research tells me I need to do another conditional that is a compound conditional statement that is more than one comparison, and my requirements were to check if the multiple is not 3 and also not 5 to display a number normally. And I found out that the not equals or exclamation point equals and the double ampersand is how you would do it. It's basically saying if x is not equal to the 3x variable and it's also not equal to 5, then we're going to display our number normally. So let's see how that works. So we bring in our resource, which is our compound conditional with the not and not, and we take out the continue because the continue was what was causing us to skip over the fizz and buzz at number 15. So let's compile that. And did it run perfectly? No, of course not. This is our first major mess up. It's real ugly. It's displaying fizzbuzz, but it's also displaying the numbers behind it. It is, however, still a building block because it did display fizzbuzz correctly. So now we got to go back and fix what we messed up. Just like any other project, take one bug out, add two more. So here we go. What did we do wrong? Let's see. Maybe instead of having that checking for if it's not a 3 or not a 5 at the end, we should probably do that at the beginning so that we don't have the number following our fizz and buzz, because that if statement was happening after the fizz and buzz, which was displaying the number after the fizz and buzz. And something I forgot to mention in the other slides, I'm doing the printf with the \n at the very end of all these if statements because we don't care which one has to display a new line. It just has to do it every time. Anyway, sorry about that. So now we move the conditional where it checks if it is not a 3 or 5 up to the top, and we'll see how this monstrosity works out. And this is where the money is made. The program worked exactly like our example that we verified with the stakeholder, who is probably bored to tears about now, wondering why it's taking you so long to do such an easy task. The only thing we have left now is to make it go from 1 to 1,000. But we know that it will work the entire way because our example covered every scenario and we verified it with the stakeholder. So we just got to modify our code a little bit. So we simply change the 16 to 1001 because we want the loop to end at 1000. As you can see from the code, it is always going to loop as long as it is less than that number. So 1001, we change it and we run it, and of course it works perfectly because we're tired of making such a simple program and having it be almost done. Let's find out what happens. And bammo, it works perfectly. It counted from 1 to 1000. It did fizzes, it did buzzes, it did fizz buzzes. It was exactly what the stakeholder wanted, even though he's probably going to not use this program after about a week or so because he found something new he wants. Anyway, doesn't matter because you got paid for it. So now you show the stakeholder and he says, ding, 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 you got it. It took you long enough. That was what, all of 5 minutes? I don't know, I wasn't watching the time. Anyway, you got it. You win. So you are done. And now that you're done, you're going to find out why they call us the stakeholder. Because you get a stake. That's right. The stakeholder actually gives you a stake. Literally. That's why they're called the stakeholder. Yeah, I'm actually just kidding about that. No stakes were harmed in the making of this video. Well, actually they were eaten. I guess you could consider that harm. But it doesn't matter, because you did the impossible. You made a fizzbuzz program. You are the next Bill Gates. You are the next Steve Jobs. You will be able to retire on this program alone. No, you'll actually have to keep doing other stuff, but that's okay, because you love it.